Yes.
All right, great. So my name is Shamar Mundal. I am a math specialist at the high school level. I'm currently pursuing my degree in actuarial science, but I'm here to help as much as I can. So my friend Kimani asked me to help you guys out with preparing for your mid-semester next week. He mentioned that its exam is next week essentially, so it would make sense that I'd be teaching. So what I'll do, I'll use the past papers to actually help you guys with reviewing the concepts and also give you some tips for the exam. All right. So what I have here, I have the mid-semester exams for 2016, 2017, and 2017, 2018. And we're going to see how best we can actually go through both of them before the session is. All right. So just a few rules, not much, just one. I mean, if you like just interact as much as you can, but don't put the others at inconvenience, because if you unmute and you have noise in the background, then you're basically putting others at a disadvantage, right? So as much as you can, if you have background noise, I'd ask that you don't unmute. If you have any questions, ensure that you ask. The chat room is there. I'll pay attention to what's happening there, and also I'll be as detailed as possible, right? So let's start. So this question here says that the growth of the population of residents of a large apartment complex in New Kingston is described by this function here. So P of t is equal to 200 e to the 0.2 times t, where t here is equal to 0, 1, 2, 3, and so on. Now, this here is what we call an exponential function, right? Don't be confused by the fact that we don't use the letter f or x as what you normally see in functions. But in this case here, we use p because it's referring to a population, and we use t because the parameter is time. So it's just us changing it to make it specific to the given scenario. Now over here is what we call the definition of the function, right? So this is what you're going to use to evaluate it. Over here is what we call the domain of the function. So the domain is very important because it tells you what value you can actually put into the definition. So you can actually put 0, 1, 2, 3. You can put whole numbers and positive or positive whole numbers only, positive and 0. All right. So it says where t is time in years, which I just said, and with t equals 0 corresponding to 2015. Now this part of the question is very important because it sets a base year. So the base year, t equals 0, is 2015. So then when t equal 1, it's going to be 2016, t equal 2, 2017. So you see basically how the values of the domain are corresponding to different years, right? So you have to pay attention to the base year here. Now it says, what was the resident population in 2015? Now in 2015, the corresponding value of t would be t equals 0. So this question is just basically asking you to find what the value or to evaluate what p of 0 is. So when I do that now, guys, it's going to give me 200 times e to the 0.2. Now remember, when you're evaluating a function, you realize that I replaced the t variable here with a value of 0. I'm going to simply do that as the same thing in the definition. So I replace it here with a 0. Now this just gives me 200 e to the 0, right? And by now, or you should be exposed to the fact that if you raise any number to 0, it's just going to give me 1. So this answer is 200 times 1. At the end of the day, it is 200, right? So the answer is 200. But if you don't believe me, let me show you it on a calculator, right? So if I put 200 times e, 200 times e to the 0, so shift e to the 0, you get back 200, all right? So you see that even if you put it in the calculator, it comes back. So if you never know, you can put it in the calculator. I'm hoping that you guys get a calculator for the exam, and that will be able to help you out. All right, so our first question is nothing too hard. I guess your teacher wanted to start stuff easy, so you feel good by yourself, right? Cool. Now it says approximately how many residents will be living in the complex in 2019. So what you have to figure out now is which year corresponds to 2019. So if you met here, guys, the difference in values. So if I look at T1, it's 2016. And how would I move from 2016 to 2015? I basically subtract it. T2 corresponds to 2017. How can I move from 2015 to 2017? That would be 2 years. So simply to find T, you can just say that T is equal to 2019 minus 2015. Does everybody understand how I get this value of T here? You can respond. Guys, do you understand how I get the value of t for there? All right, great. So when I find that now, 2019 actually corresponds to t equals 4. So all you have to do is just find what p of 4 is. So when I work that out now, p of 4 is going to be equal to 200 times e to the 0.2 times 4. You can just plug this right away in your calculator. Let me carry it over here. So 200 e 0.2 times 4. And your calculator tells you that it's approximately 445. All right, so everybody seen the 445 here? All right, cool. It's supposed to be on the screen. So let me take that off. So 445 for our second answer. This isn't so bad. All right. Now they're saying to in what year will the resident population reach 900? So the population is 900. So that tells me that this part of the function, which tells us the population size, becomes 900. So what I'm going to do, I'm going to write it and say that 900 is equal to 200 e to the 0.2 t. Now what we're going to do, we want to solve for t so that we can actually know which year it's going to be. So when I do that, I'm going to divide both sides by 200. So divide both sides by 200 for starters, right? What's going to happen? 200 cancels here. I get 1. Cool. And I get 4.5 over here because 900 divided by 2 is 4.5. So I get that 4.5 is equal to e to the 0.2t. Now I need to get the 0.2t from the power. So what I need to do now, I need to take ln of both sides. So when I take ln of both sides now, I'm going to get ln of 4.5. And ln of e, those will cancel out each other, and it will bring down the 0.2 for us. So it's equal to 0.2t, right? So to find t now, I need to divide both sides by 0.2. Both sides by 0.2 here. This is going to cancel out and give me a value of 1. So in the end of the day, the value of t is going to be t equals ln of 4.5 over 0.2. Now remember that this is t, and we need to actually find the value of t and then find the corresponding year. So now put that in the calculator now. So ln of 4.5, ln 4.5 divided by 0.2, that gives me 7.5 years. All right. So it says in what year will it reach 900? All right. So when we ask ourselves 7 years from 2015, so let me add 2015 to this now. Our answer will be around 2022.5. And realize that the closest option to our 2022 here that we just get was actually 2023. Now, what would we do with a value that was 7.5 here? Well, in my estimation, what I would do is round it off to the closest whole number. When we do that, it would round off to 8. And then you add the 8 to 2015, so 2015 plus 8 here would have given you the 2023 nonetheless. All right, so do we follow with the first 3 questions? Any questions that I can facilitate? Anything you're not clear on? All right, so let's move on. So let's look at question 4. So question 4 says that if log to the base a of x is equal to y, can be written as an exponential form. Now remember that the relationship between the logarithmic function and the exponential function is that one is the inverse of the next one. Now there's a really easy way of converting between the two of them. It's that once you remember what the base is, then you just know how to do it. So let me show you here. So this is log to the base a of x is equal to y. So this value here, a, is what we call the base, right? So the base of the logarithmic function is the base of the exponential function. So how do I convert this to an exponential function now, guys? It's this. So all you're going to do, you're going to take the base, carry it to the next side of the equation, and whatever was over there, you're going to push it up. So when we convert this to exponential form now, it's going to tell me that x is equal to, the base is going to be a, and then I'm going to push whatever value was here up into the power. So it's going to be x is equal to a to y. So the answer here is actually e. So again, simple thing to remember is that the base of the logarithmic function is always going to be the base of the exponential function. All right. So again, if I wanted to convert from exponential, go over to logarithmic, set this value, it becomes the base over here. So I would get log to the base a of x, carry this down, will give me y. So it's just like reversing the operations in a sense. All right. So that was quite simple. Now, if I have 2 to the x plus 1 is equal to 4 to the x, then what is the value of x? Now, the easiest way to solve something like this is to ensure that the bases are the same. So the base for this part is 2, and the base for this part here is 4. What we need to do is actually get them to be the same value. Now, to do that, we're going to change out one of the numbers as a power of the next one. So the easiest way to change it out is to change 4. So this is 2 to the x plus 1. I'm going to change 4 to what it's equal to, which is 2 squared. So 4 is equal to 2 squared, right? And then I'm raising that to a power of x. But there's a law of indices that says a to the m all raised to the n is just equal to a to the mn. So all it is just multiply the two values here. So what this means to me now, guys, is that it's going to give me 2 to the x plus 1 is going to be equal to 2 to the 2x. Now, what's going to happen here is that once they have the same base, right, then we can just equate the exponents. So when we equate the exponents, it tells me that x plus 1 is equal to 2x. This reduces to give us a simple linear equation. So carry this x over to the next side, because I want to group my x's on one side. I'm going to get that 1 is equal to 2x minus x. 2x minus x is x, so that tells us now that x is actually equal to 1. On an exam paper, if you don't know or can't remember how to solve it, this type of question gives you the possibility of just doing trial and error. So you can try one and see if what you get when you do the first over the left-hand side is equal to what you get on the right-hand side, and you just repeat it for all the different values. So in an exam setting, if you don't and honestly don't know how to do it, somehow try trial and error. There will always be some way to get it done. All right. So question 6. If 5 to the x is equal to 20, then what is the value of x? So simply for this question, what they want you to do is literally the same thing that we did in question 4. You're going the opposite way. If I have 5 to the x is equal to 20, what I can do, I'm going to take log of both sides. So log to the base 10 or just log. So when I do that now, I get log 5 to the x is equal to log 20. Now, whenever I have log of something raised to a power, so there's a law of indices that says log to the base a of m to the p is going to be equal to p to the log to the base a of m. Meaning you can just take the power and carry it to the front. For this expression now, I can take the power here and I can carry it to the front. When I do that now, I get x log 5 is equal to log 20. Which isn't so bad, rather. So I want to solve for x now, right? So that means I have to get rid of the log 5. I'm multiplying by log 5, so to get rid of it, I have to divide. So divide both sides by log 5 now. This cancels, and I get that x is equal to log 20 over log 5. And so here, the answer is actually C, as in cat. All right. And finally for this page, question 7. We're looking here at how do we write this expression as a single logarithm. Ready? Now, if you remember your laws of logarithms, it says that log to the base a of m plus log to the base a of